Now that you've done a geometric example, I'm going to try an arithmetic example in letter B so that we can have one of each type. In letter B, arithmetic means I'm only looking for possible patterns that could be adding or subtracting. Now I have to go from a 2 to a 162. So instinctively, I'm thinking I must have to subtract. No, that doesn't make sense. If I was subtracting, I'd make smaller numbers as I go through. That doesn't make any sense at all. So I must be thinking about adding numbers. But what do I add to get from 2 to here, to here, to here, to here, and get 162? I'd have to think about this. Maybe it's something like 10. 2 plus 10 is 22, or 12, sorry. 12 plus 10, 22, plus 10, 32, plus 10, 42. Ooh, that's way too small. So maybe I have to add something really big, like add 100. 2 plus 100, that's 102, plus another 100, that's 202. Oops, that's way too big, because I'm already too big for 162. So it's got to be something in between. But gosh, there are a lot of numbers in between. It feels like guessing and checking this might take a long time. If you have the patience to guess and check, more power to you. But if you don't have the patience to guess and check, maybe we can figure this out another way. I have to go from 2 to something, and then another something, another something, another something, to get to 162. I have to make 1, 2, 3, 4 jumps in this sequence, and I have to get to 162. So I have 4 jumps to make it happen. Now let's think about how much ground I have to cover. I have to get from 2 to 162. So I'm just going to kind of think. That means I have like a 160 digit gap to cover. If I'm getting from a 2 to a 162, I have 160 digits that I need to cover. And I have 1, 2, 3, 4 jumps to make it happen. So now the question is, wait a minute, if I have to cover 160 numbers, and I have 4 opportunities to make it happen, how much do I have to cover per jump? How many numbers do I need to be able to jump so that I can make that whole leap from 2 to 162? So I'm going to think for a second. I have 160 terms to cover, and I have 1, 2, 3, 4 jumps to make it work. So 160 divided by 4 is 40. And if you're like, wait, what? How did she do that? Watch and see that it works first. If this is telling me that I need to jump by 40 each time, that's telling me how to cover the whole gap. If I divide it into 4 small chunks, and I jump by 40, jump by 40, jump by 40, jump by 40, this is telling me that I can make up the whole gap from 2 to 162. So let's see if that works. If I jump the first gap of 40, I'd end up at 42. If I jump another gap of 40, I'd end up at 82. If I jump another gap of 40, I'd be at 122. And if I jump another gap at 40, sure enough, look at that, I'm at 162. So if you would have never thought of this dividing thing, that's why I showed it to you, because it might not be super obvious, but it does actually work. And if you don't have the patience to guess a million numbers, this might be a nice strategy to try. Now, even if you're totally stuck on the logic, I wouldn't worry too much. We're going to see this again at some point, so you don't have to worry right now about making sure it makes perfect sense. You don't even need this strategy for letter D or anything else on this page. But here's the one thing to take away from this. 40 must be the adder, because that's what's telling me what I need to do to jump from term to term to term in the sequence. I must be adding 40. So that's going to be important for my equation. Now, the other thing I need for my equation is the initial value. I have to go backwards. So now the question is, what was I adding so that something plus 40 would have given me 2? Oh crap, it must seem like some sort of negative number. That seems confusing. So what if I go backwards? What if I think about the pattern in reverse? 162 minus 40, 122 minus 40, 82 minus 40, 42 minus 40, 2 minus 40. It would be a negative number. It'd be negative 38, but it looks like that works, because negative 38 plus 40 takes us right back to 2. So it does look like it works, and that means that I know my initial value. So let's go back for a second and just confirm what we need to know. For an arithmetic equation, we need to know an initial value and an adder, and it looks like we have both of those things. The initial value is negative 38, the adder is 40. So now I can write my equation. T of n equals Initial value, negative 38, plus, because we're adding, 40n. Notice when you're writing an arithmetic problem, n is a regular size variable. It's just attached to the adder, and that's different from a geometric where it's a little tiny exponent outside of parentheses. Now that you've seen an example of an arithmetic, try question letter D. If you're nervous about that one and you're like, oh no, there's no way, I don't get this, don't worry, letter D isn't nearly as hard. It's pretty easy to figure out the adder that takes you from negative 4 to negative 8, and then you can figure out the adder for all of the other terms is going to be the same. So it's actually a little bit easier, the one I'm having you do on your own. Once you figure that out, then we'll move on to question number 5, where you can kind of work in reverse.